So indeed, we continue.
Yes, yes.
Yes. So then now is the related to the time. So if we see that we have 48, that limits the disinfection because we need up to 7,200. That is a CT. So then what we can do is to calculate what is the CT, or in this case, given that the concentration is fixed. So what is the time that we need? So for to reach the inactivation of the most difficult pathogen, that is the Cryptosporidium, then we can check what is the CT that we need. Now,
divided by 48. Okay, okay.
That we need. So in this case, we can fix the well, the CT has to be 7,200. Now depends on what we fix. If, for example, there are two options. One option, or option A, is, for example, to use the same tank. So that the same tank that has a volume of 75 cubic meters. If we use the same tank of 75 cubic meters, the contact time is the same that we have seen. So that means that the T is fixed. T is already the same that we have had, that is 12 minutes that we calculated before. So this contact time, 12 minutes, because of the volume. So then what we can do is to estimate the concentration. So if those are the conditions, then what we need is this, okay, let's see what concentration we need, and it will be the 7,200 now divided by the 12 minutes. That means that we need a concentration of 600 milligrams
600.
of chlorine per liter. This is not achievable. Chlorine cannot reach this concentration because of the saturation. So this is not feasible. So this option A, is cannot be applied because this very high concentration of chlorine is out of what can be applied. So the option B is to make a larger, or to check what is the contact time that we need, so that we can try the option B. So would be to try option B, calculate the required, expand the contact time, extend it by increasing the size of my tank. So I now will calculate what is the time that I need. I fix the concentration. For example, I can consider a concentration of 4 milligrams per liter times the T that I need. And this has to be equal to 7,200. If I fix now these values, the time, the contact time that I need is 7,200 divided by 4. And this is the time that I need. That is equivalent to 1,800 minutes. This is quite some time.
I think we must multiply 4, multiply 12, then use it 7,200 divide by 48.
Um, why?
The retention time is 12, okay, 12 minutes.
No.
Now,
Mhm.
the concentration is 4 milligram per liter.
Mhm, mhm, mhm.
Now the the quantity of milligram per liter is 48 per minute. No, no, no. 48 per liter.
Now it's 48 per liter. Mhm. No, but now it is we have to reach this CT value that has a
Okay,
value
okay,
7,200.
okay, okay.
If we are dosing the same chlorine concentration, what is the new contact time that we have to have in the system to achieve
Okay,
this CT?
okay, okay,
So,
okay.
so we keep the same concentration, but we say, okay, now what is the time? So is this 7,000? So now I solve the equation for time. And it's 7,200 divided by 4 is 1,800 minutes. Before it was 12 minutes.
Okay, okay.
Now is so, but then it's increasing from 12 to 400 from 12 to 1,000 from 12 to 1,800. This is a lot. The system has to increase approximately 100 times larger.
Yes, yes.
That is might be as large as the plant. So this is so if we use chlorine and we want to disinfect everything, including the most difficult organism, there are some limitations. So if the concentration is adjusted and we apply 4 milligrams per liter based on the retention time of 12 minutes, we can remove up to Coxsackie and ECO1, and we are going to miss Giardia lamblia and Cryptosporidium. But if we want to remove everything, including Cryptosporidium, using the same concentration of chlorine of 4 milligrams per liter, then the retention time has to be of 1,800 minutes, but maybe not easily achievable. Do you see it? Is it clear?
Yes, it's clear. But what we can do in this case?
Okay, well, in this case, there is a limit of the disinfectant, but there are other disinfectants. For example, ozone. And that's the next question. For example, it says ozone. Okay, if ozone is added instead of chlorine, this is the next question. Okay, we couldn't achieve full disinfection. We need something that needs either a very high, not easily achievable chlorine concentration or a very long tank volume. So what do we do? Well, let's see what we can do with ozone. Okay, for ozone, we can check it out. For ozone, we use the same system, 75 cubic meters of disinfection tank, and we can dose 1 milligram per liter of ozone. Can all the pathogens be inactivated? Okay, for ozone, the CT of E. coli is 0.006 to 0.002. For viruses, 0.72, 0.064, Coxsackie B5, 2.6, or Cryptosporidium, that is the most difficult one, 3.5. This is a CT for ozone. This CT for ozone is lower. When we use chlorine, the CT for Cryptosporidium is 7,200 with chlorine. Now with ozone, because ozone is much stronger, we need a 3.5 CT value. What does it mean? Let's calculate it. Let's use the same approach. So now the CT for the most difficult one, or the most difficult to inactivate organism, that is Cryptosporidium. The CT value is 3.5. Okay, so if it is 3.5 and we add 1, what do we have? Our system has, we have already from the previous calculations, the T is 12 minutes. Now, if we have a C of 1 milligram of ozone per liter, then the CT, if we add cryptosporidium, if we add ozone, is 12 milligrams of ozone per liter per minute, 12. But if we check it out carefully, 12 is already higher than the 3.5. Can you see it? Is it clear?
Yes, it's clear.
So ozone is much stronger than chlorine, and because it is much stronger, the CT values of ozone are lower for bacteria. The system can have the same CT of 12. We can check it out. We had already a CT of 12 with chlorine, and it was not sufficient. We increased it to 4, it reached 48, and it's not sufficient. But because ozone is much stronger, with a CT of already 12, we can get a full inactivation of all the microorganisms. Questions?
No, thank you, doctor. Thank you.
Okay. Do we continue?
Yes, of course.
Okay, the next question is, okay, what if now instead of ozone or instead of chlorine, what if we use now a UV disinfection system that has a capacity of 200 microwatts per square centimeter, that has an efficiency of 50%, and let's use the same disinfection tank, but now the idea or the question is, what volume has to be covered? So this is our disinfection tank. So now of this disinfection tank, if we install some UV lights, so we are going to build some UV lights on top. So we're going to put some UV lights on top of the system, like this, several UV lights. So the question is, I'm going to cover it. So what should be the volume of the disinfection unit that needs to be covered with the UV lights? How do we do it? Okay, we have the, we can go back to the values. So this is a similar approach. This is the ultraviolet dose to achieve 90% reduction. And we can see different organisms with different ultraviolet doses. 1,100 for Campylobacter, 3,900 from Klebsiella. And for UV, the most difficult one is adenoviruses. We also have Cryptosporidium. Cryptosporidium, when we use UV light, they are less resistant to UV light. So this is also interesting. So depending on the disinfectant method that we are using, the inactivation is different, because in the case of light penetrates faster, easier into Cryptosporidium. and they are not any longer the most resistant organism when you use UV light. If we use chlorine, if we use ozone, they are the more resistant. But when we use UV light, they are not. The most difficult ones are adenoviruses. And if I want to have a, let's say, complete disinfection, to have a very well clean water, either for disposal or for consumption, maybe this is, well, I'm gonna exaggerate, but maybe this design is for a drinking water plant, then I want to have the highest quality possible, or ensure that the most difficult organisms are also removed. So I can use this intensity times time value of 56,000 that will help me in removing the most difficult microorganism. So I can use or follow a similar approach than before. So it is gonna be something similar, but in this case, I'm gonna do it based on the UV light effects. So let's see what we can do. I'm gonna duplicate this slide. So now for UV light, I have a lamp. The capacity of the lamp, capacity of the UV lamp is 200 microwatts per square centimeter. It has an efficiency of 50%. That means that actually the efficiency, the net efficiency is 0.5 times 200. So the net efficiency is 100 microwatts per square centimeter. The most difficult organism is not Cryptosporidium anymore, but adenovirus. For adenovirus, I don't use C, but I use intensity. And for these ones, the intensity is 56,000 microwatts per second per square centimeter. So I can do the same type of calculation. Now, I will not change my, well, I have two options. I know the intensity, I know the IT. So in this case, it's not CT anymore because I am using UV light. So instead of CT, I have the IT value. And the IT for adenovirus is 56,000 microsiemens per second per square centimeter. I know the intensity. Then this density after the efficiency is 100 microsiemens. So I can find the time. So in this case, time is gonna be equal to the 56,000 that I need, microsiemens per second per square centimeter, divided by the intensity of the lamp, that is 100 microwatts per square centimeter. So for this case, the required contact time that I need is 56,000 divided by 100. I have 560 seconds. This is the required contact time to achieve full disinfection with UV light. How much is it? So 56 seconds. So in minutes, if I divide by 60, I will get the minutes. I get 9.33 minutes. These are the 560 seconds. My current contact time is 12 minutes. So that means, and I need only 9.33 minutes. So this also means that I need to cover 9.33 divided by 12. I need to cover a more or less approximately 77.7% of the disinfection unit or disinfection tank with UV lights. Questions?
Thank you, thank you. I think this is the best way. Ozone and UV, and I think the UV is the cheapest.
UV is not that cheap. Well, you need energy, but also there are different now alternative energy methods that can be used. And there are some LED lights that consume less energy. So UV is not the cheapest, but is the most effective. Yet you need to consider that ideally, a sand filtration unit has to be built before. Before the UV system. Why? Because UV is light. If we have some particles, if we have some suspended organic matter, if you have something in suspension, the particles will, turbidity will hinder the light penetration, and then the efficiency of the UV system will decrease. So then it's better, it's always recommendable to have the UV lights after sand filtration. In that way, we ensure that we can have a very high efficiency.
Okay, okay, doctor. Very nice.
Okay.
Okay.
So this is, yeah, this is this is the exercise with the solution. Do you have questions?
No, no, thank you. Everything is clear.
Okay. Well, with this, yeah, I conclude the session of today. Any remaining question that you could have for your colleagues?
If we have any questions, we will text you.
Okay, okay. Yeah, feel free. I have asked to prepare also some exam questions, but they will be similar to these calculations, small modifications, maybe to calculate some volumes or to calculate certain intensities or doses, but they are similar to these procedures.
In the exam, final exam?
In the final exam, I think I have to prepare two questions. So I may prepare one for chlorine and another one either for ozone or for UV.
Okay, okay, doctor.
Okay.
Okay.
Well, if there is any question, let me know. For the time being, we can close this session.
No, no, no questions. Everything is easy and clear. I think.
Okay. That. Well, that's it for today then. Thank you very much. Have a good evening.
Good evening, doctor. Thank you very much.
Thank you. All the best. Bye-bye.
Thank you. Bye. Bye.
Ciao.